The next couple examples remind us that sometimes we need to find the angles in a triangle. It's not always about finding the side lengths. Sometimes we need to find those angles. In order to find the angles of a triangle, we'll have to use our inverse concepts. So the inverse sine, inverse cosine, inverse tangent, we should be fairly familiar with them already, but we'll just kind of brush up on them, and I'll try to do that as we go through the examples here. So in question 5a, we're supposed to find the measurement of angle theta. So here's our angle theta. Looking through the eyes of that, I'm looking at the opposite side, and they gave us the hypotenuse. So opposite hypotenuse says I want to use the tangent. So the tangent of some angle theta, which we're supposed to find, has to equal a 14 to 16 ratio. Now what we want to do is find tangent. In order to undo a tangent, remember this is an argument. It can't be released any other way than to undo it with an inverse tangent. So technically what I want to see is us thinking about this. We have to do the inverse tangent of the tangent of our angle theta and do the inverse tangent of 14 over 16. Whatever we do to one side, we must do to the other. But whenever you do the inverse of one function to the other, the inverses will reduce or cancel, so theta will be the result of whatever we get from a calculation of an inverse tangent of 14 over 16. And obviously that could be 7/8 if you want to type it in 7/8, because that would be equivalent, but there's really no big push for us to simplify that ratio. So it's 14 divided by 16. Remember, anytime you use that inverse tangent key, you're going to find the angle that's associated with that ratio, and that should be about a 41.2 degree angle. So theta is 41.2 degrees. Okay, so just coming back and reviewing that sometimes you have to find missing angles, and to find those missing angles, we have to come back to our inverse trig ratios. In 5b, here's our angle theta. So if that's theta, I'm looking at the sides that they gave you. 5 is the adjacent side, and the other side is the hypotenuse. So if they give you adjacent hypotenuse, then I'm going to use the cosine of the angle. So the cosine of angle theta has to be equal to the ratio of 5 to 12. To undo a cosine, we want to use our inverse cosine to undo that. So the inverse cosine will undo taking the cosine of the angle, but whatever we do to one side, we have to do to the other, which gives us our directions of what we need to do to find the measure of angle theta. Our directions tell us, go ahead and find the inverse cosine. So do second cosine gives you your inverse. It says you're going to find the measure of an angle of 5 divided by 12. And that is equal to 63.4 or 65.4 degrees. So 65.4 degrees. So just a quick review of how we use inverse trig functions to find missing angles.